Stevens of Eurotherm by Watlow, and was asked a couple days ago now, Rich, doggone it, how do I go ahead and create a ramp soak program in a Eurotherm nanodac using iTools? So quick tutorial here for everyone. I will say this is going to be a very similar procedure on the Eurotherm EPC 3000 series and the Eurotherm 3500 series. So although it's not exactly the same, it's really close. So anyway, we'll get started here. The first thing to kind of do is we need to make sure our loop block here and our programmer block are wired correctly. So there are 4 wires that you need to be aware of. So starting with the loop block and the set point track set point output, that has to be wired to the input of the programmer block, specifically to the channel 1 set point input. That's wire number 1. Wire number 2, coming off the loop block, is our track process value output. That gets wired back over here to the channel 1 PV input. So that's wire number 2. Wire number 3 is right here. So coming out of the programmer block, we need the channel 1 programmer set point to be wired to the input of loop 1 alternate set point. And then the last wire is coming out of the programmer block. I need my run command to tell loop 1 to go to the alternate set point enable. So our wires here are 1, 2, 3, and 4. If you don't have that wired correctly, you probably will not get this to work, but we're wired up. Not going to go into this, but I've also wired a thermocouple here to my process value input of the loop, and then my control output out of the loop comes into a 4 to 20. We're not going to worry about this here. Before we get started creating a ramp soak profile, if we double click on the gray header of any block, but specifically the programmer block, there's a little bit of homework we may need to do first. So you can see here I've got some features here that I may want to enable or disable. They are currently in blue font, which means I am in read-only mode. If I want to modify that, we're going to have to log into our engineer level. And I'm sure your password will vary. So first thing is I've got a holdback, a process value event, a user value, messages, and then FTP. If you don't know what these are, if you highlight a cell, so we'll highlight holdback and then right click on it, we can go to parameter help and it'll tell you what that feature is. So I'll get to explaining this here in a minute. So in my case, I do want the holdback and the process value event enabled. I'm going to skip FTP. When I go to setup, that's the next little bit of homework we have here. So in this case, I've got the program mode access level. So who do I want to be able to get in to start a program, reset a program, so forth? Well, in my case, I want an operator. I can also lock that behind a couple other levels, so I can have it completely logged out. I can have operator, I can have supervisor or engineer. So here's the program edit. So although I want them to be able to select a program, I don't want them to be able to edit that. So I'm going to lock that behind a supervisor. I also don't want to give an operator the ability to store a program. So again, locked it out behind supervisor. If I fall down here a little bit to this power fail action, power fail is, I guess, in the scenario where I'm running a program and for whatever reason I lose power in the building. When it powers back up, how do I want to recover from that? So I can do a ramp back, a reset, or a continue. So again, if you don't know what these are, I'm going to go to parameter help. So on a ramp back, the programmer will go back to the programmer set point at a ramp. I can reset the program, or basically shut the program completely off, and it'll sit there and wait till somebody tells it to restart, or I continue from where I left off. In my case, I want to reset this particular one. Maximum number of events. So the nanodac can have 8 events per segment. And then down here, I can actually start, stop, and run the program. I'm not going to do that from here. Run, again, this is blue. This is kind of just telling you what's going on. So I've got my programmer block pretty much set up with the features I want. So now we're going to develop a program. So again, come to this programmer tab up here. And if there's a program loaded already in the nanodac, because I'm live with the nanodac right now, you may see a program pop up. But in my case, I don't have one loaded, so I want to create a new one. So the first one is segment name. So I can leave it as segment 1, 2, 3, 4, 5, so forth, or I can name it. So my first one, let's just, for example, say ramp number 1. And then I want to tell this, I want to ramp. So what do I want to ramp to? So here's my target set point. So we'll go to 100 degrees. For this example, I can do this slope or ramp a couple of different ways. I can say I wanted to go to 100 degrees in an hour. There's my hour, and it'll figure out that slope. If I want to do it so many degrees per minute, that's just another one. So what I did was come over to the program parameters. I'm going to explain holdback in a minute, but I can do a holdback based on the segment of the program or the overall program. I think in most cases, per segment's more common. Here's the ramp style I was just talking about. We're set for time. I can also do that on a rate. So if I pop back to my programmer, now instead of 100 degrees in an hour, it's 100 degrees at a certain number of degrees per hour. So I can put in 20 degrees here. Does the same thing. It calculates the same slope. It's just preference on the end customer's scenario there. I will come back to these two in a minute. So now I'm going to go to 100 degrees at 20 degrees per hour. And then what happens? Well, I want to create a dwell segment. So when I put on a dwell, it says, well, okay, I'm going to 100 degrees. How long do you want me to sit at 100 degrees? So we'll just say 2 hours. Here's where holdback comes in. My set point is going to go to 100 degrees at 20 degrees per minute. That's my set point. My actual process value may be lagging a bit behind. So all of a sudden, my dwell just took off, but my temperatures may be only at 80 degrees. You may not want that. So what I can do is I can put in a holdback. So a holdback on the low side, I'll explain this. So let's say 5 degrees. So what I've just set up is my set point went to 100 degrees. My process value is lagging. When I get to within 5 degrees below my 100, so 95 degrees, my dwell will take off. So think of it as a guaranteed time at temperature. So if I'm 10 degrees below, my dwell will never start. If for some reason my process value drops in the middle of segment 2, I'm going to hold that time until it recovers, then it'll take back off. I can also do that on the high side. So I don't really care if I'm lagging behind, but I just don't want to overshoot by 5 degrees. So if I went up to 105 or higher, my dwell segment pauses. And then the last one is a combination of both. So I can do a band. So keep in mind, 5 degrees is the total width of the band. So in this scenario, I'm 2.5 degrees below or 2.5 degrees above. If I leave that band, the dwell will pause. So again, I'll make this 20 degrees for our example. So now at a 20 degree band, I'm 10 degrees below or 10 degrees above. If I fall outside of that band, the dwell pauses. Do another ramp here. We can name, again, I'm going to show you this one more time. So we'll just call this dwell number one. So you, again, maybe means a little bit more of something to an operator. So here's our ramp. So we'll just go to 300 degrees down. We'll put in a rate of 50 degrees per hour. I'm not going to use the holdback here per se, but I do want to explain how a ramp segment is affected by the holdback. So we'll put in a low again. Very similar here. So in this case, I'm heading up to 300. If my temperature between my process value and my set point is more than 5 degrees off, I'm going to hold the ramp segment. So at 200 degrees, my set point's there, but all of a sudden my process value is lagging behind. Sort of the same thing. It'll wait for the process value to catch up, then it'll finish the rest of the ramp. So again, you can do highs, lows, or bands on ramps or dwells. So I'll put that in here just so we can kind of keep track of it. Now everything's fulfilled here. We're going to go to our last dwell segment. So we want to dwell again, let's just say for 3 hours here. So we're going to dwell at 300 for 3 hours. We'll set up our holdback again at 10 degrees. It's a 10-degree band. So again, 5 degrees above or below. So at this point, I'm ready to ramp back down. So we can say, okay, I've fulfilled my temperature. I want to ramp back down to what? Well, let's just put it closer to ambient. So maybe 75 degrees or 70. Again, I can do that at a certain rate if I want to control the ramp down. So we'll put in 50. I'm not going to use any holdback. So here, I do want to go to 70 degrees. I don't care about a ramp or a rate. I just want to get there as fast as possible. So I can use what we call a step. So here I'm running at 300 for 3 hours. When my 3 hours is done, my set point just goes automatically to 70 degrees. So that's a way to use a step. You can use a step on the way up, the way down. Again, it goes to temperature with no ramp involved. And then lastly, segment number 6 is my end. So I can end this a couple different ways. I can end on a dwell. So I am going to step this down to 70 degrees. When I end on a dwell, it stays at 70 degrees until somebody tells it to do something different. The other way I can do this is end on a reset. Notice what happened there. I went to 1,000 degrees. Well, why did that happen? When you end on a reset, go back to my graphical wiring. I go back to whatever set point is programmed in the loop. So in my loop, if I go to my target set point, I'm at 1,000 degrees. That's why it went up. It went from 70, it reset to the loop 1 set point, which was at 1,000. It's not a right or wrong thing, but it can definitely bite you if you don't know exactly why it did that. So just be aware of when you end on a reset, it reverts back to the loop 1 target set point. Come back to my programmer. We're going to end on a dwell. So just, again, that's my preference. It's totally up to you. So coming back to this process-based event, say here, when I reach 100 and maybe when I reach 75 degrees, I just want to do something. It's a trigger. I want to interlock. Maybe I need to close a door at 75 degrees. So at 75 degrees in segment 1, I can come back to my graphical wiring. Here's that process-based event I set up. Maybe I want to fire a relay. So we'll drag a relay onto our screen here. Oops. And when I reach 75 degrees, I trigger that relay. And then I can drag out a comment block and I'll say, door closes. Again, it doesn't really do anything. It just helps the engineer developing this remember what he was doing here. So we're just going to attach that to that block. I'm going to come back to my programmer. So that is a process value event. It doesn't really care where I'm at within segment one. It's just going to trigger at 75 degrees. The other way to do that is a digital event output. I can program these up here. So again, maybe I want to just let somebody know when I've entered a dwell period. I don't care what the temperature is, only that I'm in a dwell segment. So I can go in and turn any one of 8 events on or off. So we're going to do the 2 dwell segments. I want an output. So I'm going to come back here to our analog thing. So now when I come back to graphical wiring again, here is another relay. So whenever event 1 goes active, I trigger that relay. So maybe I want to just know when the dwell is active. Maybe I want to light a tower light or something like that. I can just jump or power through that relay. So do this. Tell it what it's doing. And then the last one I want to do, we have people say, I just want to know when my program's done. So you could set up an event to do that. But if I click on this little yellow block here, it opens this up over here, and down towards the bottom, there is an end output. So at the end of the program, rather than tying it to event, I just fire this relay. So maybe that's another tower light. Everything I just wired here is in green dotted lines. That means it's on there, but I haven't saved it yet. If I come up to my blue cube here, download wiring to instrument, I will connect that. And now everything is a black solid line, which means it's been successfully sent down to my nanodac. So we're going to come back to the programmer, almost done here. Saving programs, storing programs, so forth is done with these 4 little buttons up front. So this is a program I just wrote. I want to save it to my laptop. So I'm going to click on Save Current Program to a File. So here it is. So we're just going to call this Rich's Example. And we're just going to store that on my desktop. Give it a moment here to kind of catch up. So I saved it. Within the iTools environment, maybe I want to modify that. So I can come up to load a program. I can load it from my PC, find that file. So I created one earlier. So here's another example. And we can just open that and modify it here. So again, if you have programs on your PC you want to edit, you just go to this one, pick the program, and edit it from there. And then you could resave it. So the other thing is, I've got this program loaded. I want to store that program on my nanodac. So hover over that, store program on device. So it's just going to default name to current program, but I can call that whatever I want. This is, again, Rich's preference. I usually give it a number first. So program 01, and then you can give it a name behind that. Rich's Example. I'm going to abbreviate there. Now I'm sending that program down to my nanodac. If I want to see what's in the nanodac, I can go to delete a program for a device. So I'm going to go down and look at what's stored in my nanodac. The only one I have stored is that. If I had other ones, they would show up, and then I can delete, if I want to. Once I kind of give that a program name, up here, here's the program I'm working within. So again, whatever program you're editing or looking at, you should get a program name up over here. That is the basics. There's some higher level functions that I'm not going to get into in this tutorial, but let me know what you think. Drop me a line, and if you have any questions, happy to answer. Thank you. Bye.